let's understand what is Kubernetes, right? So we know containers, we try to bundle the code and the dependencies and create an image, and these images are started, they run, right, they run in the containers, right. So containers are good way to bundle and run your applications, the code, the dependencies, everything we compress them. Basically I am using the word compress, but it's not, it's actually called as bundling them, combining them together and forming an image. This image we are placing, starting and running it in a container. Container is a isolated process, right, it's a process. Okay, so it will be running continuously and your business application starts working, right. In a production environment, let's say you need to manage the containers that run the applications and ensure there is no downtime. See, your applications, basically I have some services here, front end, back end, middleware, so many services I have. All these things are my services. Okay, these things I am clubbing along with the code and making as an image. This image I am putting them in a container, in some container, and I am running the containers. So if a container is working fine, if it is running, it means the application is running. So in my application, if there are 20 services, I may have 20 containers. All containers are monitored and they should be running, they should be always running mode, right. So there should not be any downtime, that container should not go down. For example, if a container goes down, right, another container needs to start. Let's say for one service S3, I have created one image and I have kept this image in a container, let's say container number 7. If this container goes down because of any reason, right, we need to restart another container immediately. For this image, you have to restart another container, some C7 bar, I have to start it immediately. This container has failed because of some reason, but we need to start this new container immediately, so that the requests which are coming are satisfied, right. Wouldn't it be easier if this behavior was handled by a system? Instead of I manually restarting the container, see, this container C7 has failed. I do not know why it has failed. There may be a lot of reasons. If this container C7 can be automatically restarted, if I can, sometimes we know that if you restart it, it starts working. So somehow the requests which are coming to this service or this container should be redirected to this new container. So immediately I have to create a new container for this image. It means for this service, or I have to repair this container, I have to restart this container. So this is a manual process. So to automate that process, right, what if this behavior or restarting the containers or repairing the containers was done automatically by a system, right. So Kubernetes is that particular tool. It's a software which will take care of the containers. Okay, I will say life cycle management of containers. Life cycle management, creation, deletion, updating, scaling, playing about working with containers, right. Everything relevant to containers is taken care by the tool Kubernetes. Okay, so Kubernetes provides you with a framework to run distributed systems resiliently. Without fail, it will help us to run the distributed systems. Distributed systems means applications like microservices. Microservices is one architectural style which says that it should have multiple number of services. We should not have monolithic code, we should not have single piece of code. So when there are more number of services, how do we manage such kind of application? So Kubernetes will help us. So Kubernetes takes care of scaling and failover of your application, provides deployment patterns and more, right. So it acts as the brain or the orchestrator. So Kubernetes is an orchestration tool. Containerization is achieved using Docker and orchestration is achieved using Kubernetes. So it's an orchestrator for your containers, handling the complex task of managing the containers and scaling them automatically. What is scaling? If the load is increasing, let's say my container C7 is having huge load, number of requests which are coming from the users is high. Then I have to scale this, means I have to make multiple copies. I have to make multiple copies. So how do you make these multiple copies? Right? So that multiple copies can be done automatically with the help of Kubernetes. Or otherwise, if I just deploy my container in the cloud are auto scalable. It will take care of that scalability. It will take care of that increasing number of load, right? Or otherwise, if you are not using cloud, if you are deploying in some on-premise or some private cloud or some physical server, then this Kubernetes will help us in doing that. Okay, so that is about the Kubernetes. Before we go and understand more, we need to understand what is orchestration, because we said that Kubernetes is an orchestration tool. Basically, orchestra, you understand, in a music troupe we have a lot of people playing different instruments. There is one orchestra. The troupe is called an orchestra, and there is one person who is running the show, right? So Kubernetes is that one person. Kubernetes is the orchestrator. He is the manager, right, who coordinates multiple containers or services to work together automatically. So orchestration means coordinating and taking care of the containers, right? So what all things this it can does? See, start containers in correct order. Containers will be started one after the other. Then restart the failed ones. If some container has failed because of any reason, we have to restart it. Scale based on the load. When the load is high on the containers, we have to scale it. Scaling means increasing multiple copies, increasing multiple instances, and route traffic correctly. When the request is coming, right, you have to accordingly send it to corresponding services. Okay, and for achieving this orchestration concept, Kubernetes is the most widely used orchestration system. Okay, so for applications which are built based on microservice architecture, right, they need these kind of tools, because in microservices we have lot of services. When there are hundreds and thousands of services, we have hundreds and thousands of containers. So how do we handle such big number of containers? How do we visualize them? How do we know the status of those containers? All that is done in the tool Kubernetes. Okay, right. So Kubernetes, often shortened as K8, they write it like this, K8S. It means from Kubernetes to S. To S there are here 8 letters. There are 8 characters from K to S. That's why it is called as K8s. So they write like this, K8s. Okay, so this is simply notation for 8 characters in between in the name of Kubernetes. Right? So Kubernetes, often shortened as K8s, is an open source platform that automates the deployment, scaling and management of containerized applications. So software applications which are deployed based on the concept of containers, they can be managed using Kubernetes. Some important features of Kubernetes: automated scheduling, right, efficiently places containers on the nodes for optimal resource use. Okay, so we have some cluster nodes where we have to run our containers. We have some cluster nodes. Self-healing, most importantly, automatically restarts, replaces and reschedules the failed containers. If a particular container has failed, it will automatically take care of the healing or the restarting of that particular container. Then we have rollouts and rollbacks, right, manages application updates and reverts when needed. So when you want to roll back some container, when you want to restart the older container, we can do it using the Kubernetes. Most importantly, scaling and load balancing. So when the load is high, that will be taken care by the Kubernetes. It will automatically, it will do the horizontal scaling, means increasing more number of the instances of that particular application. So basically creating multiple containers and running more number of containers for a single service, right. So this is about the Kubernetes features. And finally, resource optimization, monitors and ensures efficient resource utilization. Okay, so how much resource is being used, that also will be taken care by the Kubernetes. Basically all these tools focus more on using the what we say, the resources, right? How do we effectively use the resources and manage them? Okay, this all taken care by the Kubernetes. Now, why we need Kubernetes basically? What was the main reason or motivation factor for coming up with this concept of Kubernetes, right? So, we know with microservices came with a new challenge. Instead of running one big application, companies now had to manage hundreds or thousands of small services. Basically, Kubernetes became popular. Or the other ways of saying this, when we teach microservices, right, when we talk about microservices, we always talk that we will be deploying the microservices as containers and we will place them in the cloud. It is a standard defined in the microservices, saying that microservices should be deployed using containers. That is the standard defined. So, for managing for any application which is built using microservices, it will have lot of microservices, it will have lot of services. You see, one simple UI, I have multiple microservices I have. So, when I have multiple microservices, this is a code plus its dependencies. I will be clubbing them into image and then that into a container. So, I will have lot of containers. So, that was the main reason. Actually, Kubernetes became popular only after the concept of microservices. Mostly 99.9% microservice based applications are deployed using Kubernetes. But since I said that everybody is now using microservices, in future we will not call a front end developer or a back end developer, we will be calling them as microservice developer, because that will be the ultimate style of designing applications. Okay. So, for microservices has hundreds and thousands of services in an application. So, all such application will have so many containers. So, how do we manage them, right? So, containers solved the packaging problem, but without a way to orchestrate them, things got messy. I have so many containers, C1 to C500, all these are in different random order somewhere deployed. How do we manage them, right? So, that is where Kubernetes came into acting like a smart manager that automates deployment, scaling and coordination of all those microservices. Basically, if I have microservice MS1, this will be in a container C1. If I have MS2, this is kept in a container C2. And when I say container contains the image. This container contains the image. Image of what? Microservice 3. This is container 3. Right. So, the code of that application is converted into image and that image is placed inside a container. Right. So, Kubernetes manages them very well. It is a front end tool, it has a beautiful UI Kubernetes, where you can see all the microservices, their health, you can track them, you can monitor them. Perfect tool for handling applications like which follows microservices. Okay. Right. So, this is about the containers. I hope you got some little idea about what container is doing. Basically, it is an orchestration tool when for applications of microservices, right, which has lot of microservices, I will have lot of containers, hundreds and thousands of containers. So, those containers, how do I manage them? How do I start and stop them? That can be taken care with the help of Kubernetes, right. This is just the basic understanding of the Kubernetes.